In this section, we'll see how transformations affect sine and cosine. To do this, all we need to do first is review the domain and range of cosine. The domain of these functions is all real numbers, which is again negative infinity to positive infinity. And we saw from the graphs of these functions, the range of sine and cosine are all y values between -1 and 1. Again, if you wanted to check the graph, then we saw that the graph of sine theta looks something like this, which repeated itself every 2 pi, where we had that the largest y value was given by 1, and the smallest y value was given by a -1. And since we know sine repeat itself over intervals of 2 pi, then it's defined for all real numbers. By similar logic, we could deduce the same fact from the graph of cosine. Again, the largest value on our graph of cosine in terms of y was 1, and the smallest number was given by a -1. And since our function was periodic, it was defined for all real numbers, which means the domain was given from -infinity to infinity. Now, like functions we've studied before, trig functions have transformations that affect them. And the easiest transformations to see how they affect them are the transformations that affect the y values. So let's go ahead and look at an example. Example 1, we want to go ahead and sketch the following graphs. So for number 1, we'll be looking at f of x is equal to 2 plus sine x. In part B, we'll be looking at f of x is equal to a negative sine x. In part 1, the first function that we'd be looking at is just sine x here. Now, if we apply the transformation sine x plus 2, what this is telling us is we want to raise all the y values of this graph up by 2 units, which means we're going to vertically shift this graph up by 2 units. Looks something more like this. Now, looking at the second graph here, again, if we started with our function sine x, we'd have a graph that looks something like this. And if we applied the transformation negative x, all the positive y values become negative, and all the negative y values become positive. Which means our graph looks something like this. Now, moving on to the transformations that affect the x values. Well, before we look at that, actually, let's go ahead and look at what occurs when we vertically stretch this graph. The largest value of a trig function is called the amplitude. This comes from chemistry and physics whenever we study the motion of a wave. When we want to vertically stretch our trig functions, what we'll be doing is we'll be changing the amplitude. If we write our trig functions out, we say that y of a sine x and y of a cosine x is again our trig functions that have been vertically stretched by a factor of a. This a in both terms is what we refer to as the amplitude. The only note really to say here is that the amplitude is actually the absolute value of this number a here. Now, since we have the amplitude, which again represents stretching our trig functions vertically, let's turn to the transformations that affect the x values. We know again that the functions sine and cosine have a period of 2 pi. Now we can alter this period by a horizontal stretch. This will be done by multiplying the x values by constant numbers. To do this, we'll use the following formula. The functions sine and cosine given by the following equations will have a period of 2 pi divided by k if we have the following equations. Y is equal to sine of k times x, and y is equal to cosine of k times x, where in both cases we have k is greater than 0. So now one complete period is completed over an interval of length 2 pi divided by k. As a quick example, if we had our function sine x, and we were only looking at the period from 0 to 2 pi, then if we apply the transformation sine evaluated at 2x, what this will do is it will change our period from 2 pi to 2 pi divided by 2, which will be pi. This means that our function sine x will be shrunk into the interval from 0 to pi. Let's look at another example. Example 2. What we want to do is we want to find the amplitude in the period of the given function. Again, we're given the function y is equal to 1 plus 10 cosine of 3x. Our 10 refers to our amplitude, and the absolute value of 10 is again 10. Here, this 3 determines our period. To find the period, we take 2 pi and divide it by our 3, and so our function is going to repeat every 2 pi divided by 3. Finally, this one is saying shift up by 1 unit. Now let's go ahead and look at the last horizontal transformation. This will be a horizontal shift. If we want to shift our graph in either the left or right, what we'll do is we'll replace the x with x minus b. And to determine how these shift, if we have that b is larger than 0, then we shift left. And if we have that b is less than 0, then we shift right. Whoops, this is actually in reverse. This should have been less than 0 to shift left, and this should be greater than 0 to shift right. Let's summarize all these important transformations on our trig functions. Again, we have two functions, a of sine of k of x minus b, and we also have y of a cosine of k of x minus b, where in both cases, a determines the amplitude, k will determine the period, and b will determine the horizontal shift. Let's use this information to find the amplitude, the period, and the horizontal shift of the following. After we've done this, let's go ahead and sketch the graph. All right, the function we're given, y is equal to 3 cosine of 2x plus 7 divided by 8, is not in the form that we need to determine all the information. So let's go ahead and pull a 2 out of both of these terms here, and we'll rewrite the function as y is equal to 3 of cosine of 2 times x plus 7 divided by 16. Now we can determine all the information. Again, 3 is determined by the amplitude, and since 3 is a positive number, again, the amplitude is just going to be given by 3. 2 determines the period. The period in this case is going to be 2 pi divided by 2, which means the period is pi. And then finally, we have this 7 divided by 16 here, which is going to give us our horizontal shift, and we're going to shift left by 7 divided by 16. So we can go ahead and do this. Let's let the green curve correspond to our function with an amplitude of 3. So this green curve will be y is equal to 3 cosine of x. And let's just only draw from 0 to 2 pi. And then the blue curve will be our horizontal compression. So we'll take this, and it will be done in half. And then finally, our black curve will be the complete function, y is equal to 3 cosine of 2 times x plus 7 divided by 6. And we're just going to shift the blue curve over by 7 divided by 16 units. And this black curve is going to be the sketch of our graph.